We're determining whether the following converge or diverge. An important note right off the bat is that this up here is a sequence, whereas this down here is a series. If we want to know if a sequence converges, we simply have to take the limit. And we're taking this limit as n goes to infinity. Noticing that the numerator and the denominator both have an n, and the highest power on n is just 1, it makes sense for us to multiply both the numerator and the denominator by 1 over n. Multiplying 7n times 1 over n gives us a 7 in the numerator, and distributing this 1 over n through the denominator gives us a 3 over n minus 4. Now we're in a position where if we take n to infinity, we get 7 over 0 minus 4, or we get negative 7/4. And since the limit as n goes to infinity of our sequence is a finite number, our sequence a sub n converges to negative 7/4. Given this result, we know the answer right away to whether or not our series converges. Since we found in the first part of this problem that our sequence a sub n converges to negative 7/4, we know that this sequence does not converge to 0, and the nth term test says that that means our series diverges. To give you a 30-second reason as to why, if we tried to add up all of the terms in this series, we'd have a bunch of numbers and we'd be adding all those numbers together in the series. And eventually, as n got really big, each number in our sequence is getting really close to negative 7/4. So as our n gets really big, we keep adding a bunch of numbers together that are really close to negative 7/4. Well, this is an infinite series, so this process goes on forever. And if we add an infinite number of terms that are really close to negative 7/4, that series is going to add up to negative infinity. That means that this series diverges, and that is why a sequence must converge to 0 in order for its corresponding series to even have a chance of converging. Okay, I hope that helps you out. Let's get some more practice in the next video.